Okay, welcome to the Unit 2 Lesson 4 video on solving by square root and completing the square. So today's video we're going to be looking at solving quadratic equations by taking the square root of both sides and also converting quadratic equations from standard form to vertex form by completing the square. Okay, so first let's look at solving by finding the square root. Now this can be a useful method when we have quadratic equations that have an x squared term but doesn't have an x term. So if it was x squared plus 3x, we couldn't take the square root of this because there's multiple x terms with different degrees. But if we just have an x squared with no x, then those are the types of situations that you can solve by taking a square root. So we have a couple examples here. Let's take a look at this first one. So again, the first step is to isolate the x squared term. So we'll add 21 to both sides. And then we have 3 times the quantity x squared equals 21. And then we'll divide out that coefficient. And we're left with x squared equals 7. Okay, so now we can do the inverse operation of squaring, which is taking the square root. And we end up with x equals plus minus the square root of 7. So this is an important aspect here because we don't know if the x value is a positive or a negative, so we have to account for both solutions. Let's take a look at another example here. In this one, the x isn't squared, but it's inside of a parentheses that is being squared. So let's first isolate that parentheses by dividing by 2 on both sides. So we get x minus 1, the quantity x minus 1 squared, equals 9. And then we'll go square root both sides of that, and we get x minus 1 equals plus minus 3. All right, so anytime you have a parentheses with a square on the outside, if you take the square root, the inside of the parentheses doesn't change. But we will get a plus minus 3. So now I know that x minus 1 equals 3, or x minus 1 equals negative 3. And now I have to solve both of these equations. I'll add 1 to both sides and get x equals 4, or x equals negative 2. And there are my two possible solutions for this equation. All right, so pause the video, attempt this practice problem, and then I'll come back and show the work and show you what you should have got. So pause the video now. Okay, so you should have x equals 3 or x equals negative 9. If that is not what you got, you should pause the video, look back over my work, and check what you did and find out where you made the mistake. If you have questions, we'll talk about that tomorrow in class. And that's solving by finding the square root of both sides of an equation. We'll look at now completing the square. So completing the square is a useful technique when we have an equation that's in standard form and however it's not factorable, or we're not able to see how to factor it. So completing the square is a nice way to get it into a factorable form, or also a way to write it in vertex form. So to understand how to do that, we're going to first start with understanding what it means to square a binomial term. So if we look at this parenthesis here, x plus b squared, if I was to do this, that means x plus b multiplied by x plus b. And if you FOIL that, you multiply that out with distributive, you'll end up with x squared plus bx plus bx plus b squared. And then when we combine that, we end up with x squared plus 2bx plus b squared. And this form here is called a perfect square trinomial. When things are in a perfect square trinomial form, you can factor them back down to their squared form, x plus b squared. So understanding how that comes about, we can take a look at how to complete the square. Okay, so if I was to now work backwards to complete the square, and I have this for any value here, let me get my pen working, x squared plus 2bx plus b squared, right? Now this right here won't ever be 2b, it'll be some number. We could call it k if you like, or we'll see in examples. But basically, I know that this number will need to be divided by 2. And that would get me b. To get the last term, I would then square that value. And that gets me back to x plus b squared. So whatever this value is, if you divide that by 2, you'll find out what b is in the form x plus b squared. Now, the sign here is very important, because if this is a positive number, then this will be a positive in the parentheses. If it's a negative 2bx, then this would be an x minus b, right? And we'll see some examples where they're different from each other. And let's just kind of practice how this works with some actual numbers. So I have this expression, x squared minus 4x plus k, right? And I'm trying to figure out what to put here for k. So my term here is negative 4. So I'm going to come down here and say negative 4 divided by 2. That would give me a negative 2. So if I was to then square that value, I would get a positive 4. So x squared minus 4x plus 4 is now in the perfect square trinomial form, which I can then factor into x minus 2 squared. Here's another example, and this one actually uses a fraction. We'll have an odd number, but it won't be too bad. So we'll take the number positive 5, divide that by 2, and I get 5 halves. Now all I have to do is square that value, and I'll get 25 over 4. So if I have x squared plus 5x plus 25, let me write that a little better, then I've written this in a perfect square trinomial, all right, which can be factored to, again, pen, the quantity x plus 5 halves squared. And that's kind of the process we're going to be looking at here. So try this practice problem, see if you can figure out what k would be to make this expression a perfect square trinomial. Pause the video and try to find k. Okay, so you should have the expression x plus 7 squared. You should have found k to be 49. If that is not what you have, again, pause the video, look over my work, and see if you can figure out where the mistake was. All right, let's go on to the last stage of this, which is solving quadratics by completing the square. So in this case, we actually have a full equation. And we can find that process of trying to create a perfect square trinomial on one side of the equation so that we can factor that and solve. So what I'm missing here is a constant value after the 6x. So I'm trying to figure out what I would need to add to this expression to make it a perfect square trinomial. So I'll take my 6 and divide it by 2, get 3, square that to get 9. So if this was the quantity x squared plus 6x plus 9, I could factor it. So what I'm going to do here is add 9 to both sides of the equation, which I'm allowed to do. Now it's a perfect square trinomial equal to 11. So factor that to x plus 3 squared equals 11. And from there, you can then take the square root of both sides and get x plus 3 equals plus minus the square root of 11. From there, you can continue to solve by saying x plus 3 equals positive root 11 x plus 3 equals negative root 11, which means x is equal to negative 3 plus root 11, or x equals negative 3 minus the square root of 11. And then you have successfully solved this by completing the square and taking the square root of both sides. So let's try another example. And this one, it's not quite set up for me properly. So what I'm going to do here is first clear this space by subtracting 5 on both sides. So I get x squared minus 8x, and there's going to be some value here equals negative 5. So if I take that negative 8 and divide it by 2, I get negative 4, and if I square that, I get 16. So I'm going to add 16 to both sides. From there, I get a perfect square trinomial of x squared minus 8x plus 16 equals 11. They won't always equal 11. It just happens to be that case today. So let's factor that, and I know that's x minus 4 squared equals 11. So then from there, take the square root of both sides, and x minus 4 equals plus minus 11. Now, I'm okay if you just go ahead and add 4 to both sides here and say that x is equal to 4 plus minus the square root of 11. And you can write both answers in that form as long as you understand that that is two completely separate numbers as it was here, right? So let's try one more. And again, if you notice this one, the 14x is over on the right side while the 27 is on the left. So again, it's just a matter of manipulating the problem so that we have the x squared term and the x term on the same side and the non-x term on the opposite side. So now that we've got it set up, we'll just continue this, square that. So we get x minus 7 squared equals 22. Take the square root of both sides. X minus 7 equals plus minus square root of 22. So x equals 7 plus minus square root of 22. Now you want to check to make sure that that radical will reduce, because if it will reduce, you need to simplify it. In this case, square root of 22 does not simplify, so you don't need to worry about it here, but you should be paying attention and making sure that you're checking to reduce your radicals. Okay, so 3 practice problems. Pause the video, attempt these 3 problems, and then come back and check your work, and that'll be it for today. So pause the video and try these 3 problems. Okay, so here are the answers to the 3 solutions. And you should be able to see this work here. That's how I did this one. Then the work was down here. But these are your answers: negative 5 plus minus 4 root 2, 6 plus minus 2 root 15, and 3 plus minus 2 root 6. So again, be careful. If you're not reducing your radicals properly, then you're probably having a little bit of trouble with that. If you have any questions, let us know. But this is solving by taking the square root and by completing the square. All right, see you in class.